So, is everyone can hear me and see my screen? Do you hear? Okay. Um, Hello everyone. I am Zeeshan from Middleware Practice, and I hope everyone will join. I see 23 people already joining this session, and I'll give a couple of minutes to more people to come. Okay, so let's start. This session basically is a little introduction of the web services, and technology is changing. A few years back, we were doing integration and other type of work without using any technologies, web-based technologies. So now things are moving towards cloud and mobile. So the function understanding of web services is now critical skill, and everybody must be aware of how web service works. And going forward, you will see everything. Different systems are integrating together. They are built on different technologies, and every major enterprise have multiple systems, uh, ma- uh, different databases like Oracle SQL Server, MySQL, and application built on using different technologies. Some application built in .NET, some, and more acquisitions are happening. Companies are merging, like PeopleSoft bought by Oracle and JD Edwards and all. So the integration between these systems are very critical. So in modern technology, this is all happening through web services. So basic understanding is now very important for every IT professional, and I'll try my best to actually give you very good overview of how the web services works and what the purpose of it, what different types of it. So after this session, everyone will be have this skill, and they will understand and talk about web services and design their system going forward to utilize web services technology as well. So little bit about me. This is my picture, how I look. I see a lot of people working remote and all this, so we don't really much interact at AST. So that's, if you see me somewhere in conferences, so that's how I look. I've been working with Oracle products for over 15 years. Uh, Started with my career with the database like a SQL developer. I worked with Oracle Forms and reports. And going forward, I switched to middleware, where Oracle trending this with Oracle ADF and all this technology, SOA technologies. So I started exploring that option and did my transition 7, 8 years ago. I'm a IT blogger also on this website, baigzeeshan.com. Uh, so my contribution to Oracle community through this blog, Oracle Corporation awarded me this recognition, which is called Oracle ACE. So I'm proudly a member of Oracle ACE community. The benefits of it, so my interview was published in Oracle magazine as well, and I get a special pass for Oracle Open and other conferences. So this is very good recognition, and everyone can do it through. There are few steps you have to follow to actually get this recognition, and you can also uh, uh, connect with me on LinkedIn. This is my URL. So next slide. So agenda for today is we'll see what is a web service, what web services do and how they work, and we'll see what kind different type of message formats we use in web services, different standards of web services. Then we'll see some demos of how to create and build very basic web services, how to test them, how to secure them, and I'll take your questions and answer them. So this is my agenda for today. Starting with the quote of Einstein, makes everything as simple as possible, but not simpler. So the same thing uh, web services do. They are very easy concept, the simple purpose of web services. But once you integrate different systems and use, so it is not very simple. But you have to have a concept of it, like what you are doing. So first question is, what is a web service? So in simpler word, it's a framework for a conversation between two devices. Framework previously enterprises they had a very huge challenge when they 10 years ago, when I see my experience, it was very difficult to actually integrate two different systems. Uh, and web services being in the industry for over 15 years now, early 2000s, and they got matured, and the couple of standards came throughout. So the 10 years ago, like 12 years ago, I see my experience. It was a huge challenge when you need to integrate two different systems in a enterprise. You have to buy special adapters, or you have to do some kind of huge customization, which nobody knows about. There was no standard way of doing communication or integration between different systems. So you are dependent on some vendor. Uh, but the standards came through, which is called web services, started by a Microsoft organization, and then these things got matured, and now we have very different couple of standards, which I will cover in uh, next slides. So the basic purpose of web service, in a simple word, is it does integration between two different systems. You have one application built using Oracle database and Java, but you want to share that data, that information to your .NET application. So what you do, basically, you build a web services. So both technologies, they understand the same standard. So that's basically the purpose of the web services. So what web services do? The main benefit of web service is that it hides the complexities between the devices. You have operation you want to do through mobile device. For example, you want to create a contact, and that contact, when you create in your mobile, it goes to some other database also. So that you can do through web services. But the front end, the people, the devices using those web services, they will not be aware of the complexity what you are doing in the behind the scenes. Same example you take as a PLC equal stored procedure. Most of us are very familiar with these. So stored procedures, you just expose the front end interface, you pass some parameters. Behind the scenes, you are creating cursors, if then else conditions, looping, and all these complexities. Front end developer don't need to know about it. So that's basically web services do. They hide the complexities between devices. So you expose your functions and operations from one systems, another system can leverage that. Web services also communicate through open protocols, like very simple HTTP protocol can be used to actually communicate through different operations. And that was not possible a few years back. Now, the popularity of the mobile devices and all this, so you have to create your systems and your operations uh, uh, reusable enough, so you can actually use the same code to your mobile devices and to your web-based application. So that is possible through web services also. You write one piece of function operation and you expose those functionality as a web services, and your other devices can actually utilize those web services. So you actually write less code. And the web services works with a specific message format. So you have a standard format like XML data, JSON format, which I'll cover in the next slide in detail. So how these work? So if you see the slide or little image on the right side on the screen, you see the device A and device B. So you have a requester which requests the data over the network. The network could be a web, and uh, device B, which is a service provider which has hosted those web services, they will respond. So the functionality is very simple. There is device A will request some specific data and device B will respond to it. And that will be very specific message format. So for service providers, they expose the data and to the rest of the world through network, or it could be a public network, and it could be in different format of your choice. You want data in CSV format, you want in XML format, you want in JSON format. So it depends how the service provider and how you have built your web service. And requester will be aware of that what operations the requester needs to call. But it doesn't needs to know what database service provider have used, what a user interface is built on, and the data is coming from flat file or a database. It doesn't requester doesn't need to know that. So device A will not be familiar with the complexities of the web service, but it will be aware of that I'm requesting this operation, and I'll be getting this data in that format. So we'll see some examples of it. Uh, One example I can say that, for example, requester request uh, passes the parameter of employee ID, and I need to know the full name of the employee. So my web service will return the full name from any database. For example, the employee stored in a SQL Server database. The HR from HR system could be a different system from the cloud or somewhere else. So I will just pass the employee ID to that web service, and that web service will go and query the cloud service or some whatever it's supposed to do and give me the data back. So there are two major components: service requester and provider. So web services are quite popular in today's world, and we are probably some of us are not aware that we are using web services on daily basis, but we are not aware of it. So let's see some examples of web service. First example is the Yahoo Weather API. So for example, you have a web page and you want to a web page or your application, and you want to keep update what's going on in the weather. So you can query the data from Yahoo servers. They keep updating the weather. You don't have to maintain it. Like for example, you're building a system for some fire fire company, and they want to know that what is the temperature outside and inside. So you don't have to collect that data about weather. Yahoo already does it. You can leverage the API they expose, and as you see in the slide, you have two choices of using the responses. Either you want to use JSON or XML, and they give you how you will write the query, and you will get this format response. So uh, you will go to this website developer.yahoo.com. You can sign up, and then you can start using these web services in your application. So there is some limit to it that you can query uh, this many requests per day or per hour, But if you buy some web services companies, they allow you to purchase a plan based on your request. So we'll go through it. Another example is a flight data. For example, there are you see many mobile applications. You see every time uh, they update the flight status. So what they do behind the scene, basically, they are using some flight aware or similar kind of APIs, and they build their application on top of it. So FlightAware, actually, it's a commercial product. You buy these APIs and then you can leverage in your application. If you see down below, uh, you have PHP, JavaScript, and Ruby. These are the examples how you can actually call these web service in your language. For example, you have application built in PHP and you want to update the flight data or give suggestions to your users or something about the flight. So you will, this is the code, sample code to actually call this web service. Another example is Oanda currency exchange. Uh, daily, most of the applications they required a daily update of the currency exchange rate. So this vendor actually provides you the daily currency rates in any currency. So you just pass what is your base currency and what you're looking for. You're looking for Canadian exchange rate or British pound or others, and you just pass parameter and it will give you the format in a different formats. So another thing, these are like commercial examples of it. We'll see some public example of web services also. Uh, Benefits of using web service. I explained some already, but the thing primary purpose of web services most people are using is to integrate with other systems. So you have different compatibility issues between two systems. For example, you have your application built in Java 1.4 legacy Java, and your new application is in modern Java EE6. So you want to integrate both. The best way is basically expose some functionalities through web services, and both systems can talk to each other through that. You can create reusable components because the interface, you will define the interface that other applications can use, and behind the scenes you can, for example, if something changes for you, you change the database servers or you change the database vendor, the front end will not change. You just change the implementation of the web service and everything will be keep working. In modern design, modern world of development, uh, you hear the term SOA or SOA a lot. The SOA stand for Service Oriented Architecture, and the base of SOA is basically web services. SOA, in modern way, basically you build your application in a way like a blocks, building blocks or Legos. You build on top of each other. So each component basically can take out, but the whole structure will be there. So you build a different blocks of services. So they work together. But if one piece is not functionable, the whole application will not disturb. So only that function you can disable it or take it offline, and the whole body will work. So that is basically a modern way of developing applications through web services and so on. So also the benefits of using web services is, for example, you have a vendor or you have a partner. You want to send some data from your system to others, so you can expose those data through web services to them, and they can use those web services and import into their system. Instead of, like, for example, you send a text file every day. Like, I've seen some people, they create a text file, then attach the email and send it to someone. people open emails or not, they missed out. So one way of doing things, like you create a web service, you expose them, you give them the URL. Okay, now you can use these web services and read the data whenever you need. So you can automate that process. Also, I gave some example benefit of using web services. Your Java based application can send data to your .NET application through web services. Before that, you have to have some kind of either you connect directly to the Java database that Java application is using, or something. But through web services, you don't have to know the database credentials and all this. You can actually work with the web services throughout. Another example is EBS system can be leveraged by cloud-based applications. So the data from EBS system, you can expose that data as a web service, and your other clouds application actually can read through it. So that's some of the benefits of using web services. So let's see a little demo of some public web services. So I'll go to my browser. I have this web services, public web service. If you just Google it, for example, public web service API, for example, so you'll see many examples of it. I just picked this first one. So this is web services exposed on from this website. It will give me the weather information, whatever zip code I provide, or information I provide. So these are operation exposed by these web service, this web service, this is specific web service. So I know what I am actually going to call. I want to know what is the weather uh, by zip code. I just clicked on it. So these web services need a zip code. So I'll just put my zip code and click send, and I get the data in XML format. You see, we will cover the XML format later in the session. So you have date coming in, you have weather ID, you have description, sunny, you have temperatures. So I can now use that data in my application, whatever my purpose will be. I didn't have to know what technology they are using, what database they are storing this data, what attributes they have. I know only I passed a zip code and I got the data. Now I know these are the attributes, and based on that, I can leverage the data. So basically sharing data between the two different systems, and these everything I'm doing through HTTP. So this is one example of using the public API. Let's go. Just you have to register for other APIs. Let's see the Yahoo one. Just give you the feel of what it does. So basically, this is the style of query you write, and you this is the response you get in JSON format. And if you click on XML, the same data you will get in XML format. So this is basically Yahoo is providing you the service, and how uh, they are providing you two types of data exchange. And as I mentioned, this is commercial API. So you have like 2000 signed call per day. So this is the limit. You can only call this web service 2000 times a day. And you have these are the things you have to do it. You have to get API keys. I'll explain later. And these are different language code samples. If you're calling from your JavaScript based application, you use this code. If you have Objective C, which is developing iPhone apps or iPad apps, so you use this. Node.js is modern, latest technology, programming language similar to JavaScript. PHP, Python, and curl. Curl is basically a command prompt you can get through Unix. In the Unix, you just type this and get data on the command prompt. So these are the some example of the public web services. We so hopefully everyone knows now that what web services do. So let's talk about message formats. Web services they expose data as you see in either JSON format, XML format, and other formats. So we'll see some popular message formats that everyone should be aware of. So there are like two message formats that web services mostly work. One is XML and other is JSON. What XML, what JSON it? Let's dive into it. So XML we have been using for quite some time, everyone. So it will be easy to understand. So XML stands for Extensible Markup Language, and the primary purpose was to develop XML is to describe data. Describe data, uh, as in the next slide, you see on the left side, I have a plain text, John Scott reminder team meeting. Computers cannot understand what John is, what Scott is, what reminder. So these texts basically is difficult for computer technology to understand. So there was a need to some kind of standard to come to actually uh, mark these data so computer technologies or web can understand. So since then like XML was born, and on the right side you see now I have these tags, first name and last name, employee, and different systems. So these tags basically will tell me that now this data basically belongs to an employee record or a first name and last name. On the left side, actually, now I realize I forgot to update it. So I should put the plain text of the employees. So anyway, sorry about that, but compare, that was my first example. So now this, if you see the whole employee XML document through XML, I can say my plain text, this could be, John could be a from message, Scott could be a to message, reminder could be a subject, and team meeting is a body of the email message. So that was an example of my, we'll see in the next slide. XML syntax. So everything you have to do actually define the data within these tags, element tags. So you start on the top right, you see the employees, the blue line. So this is the starting tag, and at the very end you see the employees with this backslash, which is closing tag. So now computers understand the starting point for employees record is that starting tag of employees, and this is ending with this slash employees. So it will read from this complete array from start to end, and it will be aware of. Inside that you have a employee red tag on the line number 2. Red tag starts, and inside that you have first name and last name tags. So computers know that this John is basically a first name, and Doe is basically last name, and this is one employee record with the ending employee tag in red, and then it starts the next employee information. So it could be you could have more elements of XML there, like date of birth, social security, and address, but every employee starting tag will end with this employee, so computer will know this is the complete employee record from. So this is basic XML. We'll see more examples. Oracle technology is using XML for a very long time. You can also store XML data in the database. So current products of Oracle developing web services, the first choice is basically XML. So all products and the things are so slowly going towards other formats also. So XML you will be using quite a lot. Same, he's Tim Bray, basically photo of Tim Bray. He's a founder of XML. And you can see now in a picture, you can describe uh, a different parts of the picture through XML. So computers can understand, okay, from here to here, it's hat, it's a button. So this is a funny way of explaining the XML. And these tags, basically at top, you see photo by Alex, uh, Greek, geek named Tim. Basically, these are metadata that you can attach with your document or some file. So computers can understand what kind of document it is, what is the date created, and all these different attributes that you need to know about working working with the data. So XML played a very huge part in the success of the web technology. And for past 10 years, whatever technology was developed, basically XML contributed a lot because you are now aware of the data components and all different things, and a lot of framework actually built on top of XML using XML style syntax, uh, Java based JSP, and all these technologies using these kind of syntaxes. So next format is called JSON. JSON is the latest. It's coming along like for past 3 years, you can say, getting popular. It's called JavaScript Object Notation. The XML sometimes, like when as the technology is growing, you see XML data becoming very complex to understand, and it's not very human readable with all these hashtags and all these tags and all these huge files. It's very difficult to handle also, and the performance and the size of data grows up. So the new standard, new type of data message format came. It's called JSON, which is a lightweight, and popularity of the JavaScript based applications and web pages. JSON became popular, and it's easy to use, and it's alternative to XML. So you can actually use both formats for your web services. I'll explain where the JSON format people prefer and versus the XML. If you want to learn more about JSON, this URL you can go, and same I have put a URL in XML overview as well. So on the left side, now you see, again I forgot to update this, but same employee information in JSON format. You will do like uh, you will say employees one time, and then you have brackets. So we do like in maths this kind of curly brackets and large brackets a lot, and now we will be using in computers again. So that's how basically you describe your data. In the next slide, I'll explain the syntax. So in JSON syntax, basically you put data in a name value pair. But the start of the data, like in this first point in the black, you see this name, first name, colon, John, last name, colon, Doe. And same thing, the curly brackets basically holds the object. So starting of the curly bracket and ending will tell this is the employee record. And the next starting of the curly bracket ending will tell, okay, this is second employee. And the third will do the same. And the square bracket basically will tell us the array. So we have employees, which is many employee, like we have three in this case. So employee 1 is John Doe, employee 2 is Anna Smith, employee 3 is Peter Jones. So this is easy to read, you see, starting with the bracket and name value pair, and it's less complex compared to XML. In XML, you have too many tags which increase the size of the data. So, which increase the size of data. So JSON basically uh, help to keep the data minimum, which increase the fast performance, and it's easy to use through HTTP protocol in the browser. So you understand now the message formats. We covered XML and JSON. XML uses tags, and JSON uses brackets to describe the data. Now let's go to the web services standards. How many types of web services are there, and how we work, what are the difference, and what is the purpose of each. So there are two types, major types, like there is third one also. uh, Two types of standards. One is called SOAP, another is called REST. So SOAP is developed like 10-15 years ago. It got matured and it used heavily in the enterprise community. And the REST is recently becoming popular, like past 5 years, you can say. And this standard is coming along, and it's basically easy to use and fast, and will go through it. And the third type is also called OData, which is developed by Microsoft, and maybe in future you see some people using it, but so far these two are the top of the line standards for web services. In Oracle community, you will see SOAP being used for quite some time, and the rest, now Oracle products actually adopting REST features, and through that basically mobile technology is going forward through REST. They are adopting a lot REST, and why it is, I'll explain in the next slide. So let's go through the SOAP. What is SOAP? SOAP means Simple Object Access Protocol. So you take initials of all this, and it's called SOAP. For SOAP web services, they relies on XML message format. Strictly, they use XML message format, and it, SOAP services, you have to have a document which defines the features and operations of the web services. It's called WSDL document, Web Service Description Languages or Definition Language. Uh, on the image on the right side, you see on top, you have a WSDL document. And WSDL document, basically you define what type of operation my web service expose, what the input parameters are, what are the output parameters are, what are the exception handlers are. So it's very strict to it. So you have to have a kind of contract to use it. Basically, you need to have a WSDL document link URL, and you create a proxy client on your client side to that WSDL document, and then start using that web service. But the good benefit of SOAP is enterprise, which requires a standard. So they actually adopt it a lot, and so SOAP is very enterprise way of working with the web services. So in the slide, I'll explain the architecture of it. On top, you have WSDL document. You request SOAP request from the client application to service provider, but the WSDL document will be involved throughout in your request. So through WSDL, your client will be aware that what features and operation your service provider is providing. So the problem is, if your service provider change the WSDL document, then you have to update the client application again to actually update the latest operations, or or if there is a new method added in the web service, then you have to change the WSDL document. REST, on the other hand, called representational state transfer, and it's based on the very basic HTTP based verbs like get, post, put, and delete. Uh, so the popularity of REST, because of the simplicity, you don't have to have a contract. You don't need a WSDL document or any strict contract. All you do is basically send the HTTP request through your devices. Like it could be a client or it could be a smartphone, and you just request the your operation uh, to the web services. In your format you say, okay, I need XML format or JSON format, and the data will be back to your device in that format. You don't need any contract, so it's very programmer friendly. So most of the new web services development is going through the REST web services. Easy to use, lightweight. You don't have to have a WSDL document complexities working with the WSDL documents and stuff.
What do you mean by contract?
Contract means there is a question, what do you mean by contract? Contract is basically a WSDL document. In like going back to the previous slide, in WSDL document you say, okay, my web services expose these 5 operations and I'll be using these 5. But in REST you don't mention it in your application that these 5s are available and you will be calling out of these 5. In REST, you just call a simple URL, HTTP request, like you do a web browser, simple like in Google when you click, you type search and hit search button. Behind the scenes, they might have a lot of web services that actually do pull data from different locations and give you the response. So we'll see that in the demo, like how to build. So SOAP versus REST. This slide will tell you on the top left side, you have a WSDL document, you have a SOAP message. You WSDL document basically publish your SOAP web service, and these items are required for any SOAP operation to work. On the top right, you see client application. It has a SOAP body, and it's over the network. It's actually pass the SOAP message to web service and get the response. On the other hand, in the down, you don't have any message or envelope going. It's just basically client application calling the HTTP request to the web service and getting the data. On the SOAP message, you actually prepare your message in a proper format. Okay, I need this format, this data, and then send with the requested parameters to web services. So we'll see in the example how they work. So other example, the popularity of REST. On the top, you see you have your data, plus you add your SOAP standards. Result, your data will be huge and chubby to the server. On the down, you see your client application. You just send this data directly to the server. So you don't have to involve any standards or WSDL documents and complexities with your data. So that's became a popularity of mobile devices because REST works directly with the data, so it's faster. And mobile, they are have very short, limited memory and the data size, so they popularity of REST, basically mobile community adopted REST everywhere. So next is what tools we use to actually build web services. So let's dive into it. So web services you can build in any technology, as most modern technologies or tools they support it. For example, you have Oracle J Developer. You have Eclipse, which build you can build Java applications and anything, and Microsoft Visual Studio for developing Visual Studio. So basically, it's not technology specific web services. It's basically a standard which adopted by all different vendors. So it's basically an open standard. And SoapUI point number two is basically a popular open source tool which we use for testing web services. You can actually send bulk requests to test, okay, can your web services handle this load or not? Or you can play with the different parameters and formats. Uh, eh, there is also a Chrome extension called REST console, so you can actually pass the URL to it and play with different formats. You can test your web service in a web browser. We'll see some examples. Oracle HTTP Analyzer is a inside a build tool in JDeveloper you can use to test your web services, and also on Oracle Enterprise Manager, which we use commonly for all web logic and other stuff. So there are like options to actually test and verify your web services. So some real world use cases. Uh, Inbound and outbound data from cloud-based application to on-premise app. That's that requirement we can do through web services. For example, your cloud-based application, you need to read data from it, or you need to import data into cloud applications. This is possible through web services. As far as your cloud application allows it, you can do it. So we are currently doing at City of Detroit. So use of web services is very important. Most of the task, if you want to automate, you can do through web services. Otherwise, there are like a long manual process, which is very error prone to the users, and it takes a lot of time. So we can write code, call these web services, work with them. So it will be automate a lot of things we can schedule, that importing data from other systems to other system through web services. Next example is compatibility issues. So at College of American Pathologist, we had a use case. Uh, there was a legacy Java based application which we wanted to integrate with modern Oracle identity manager tools. So what we did basically, we create a middle web services layer which reads data or update data into OIM. For example, when a new user created from their legacy web application, you want to actually create user in Oracle Identity Manager, which is the security middleware product. So what we did, we create a web service which creates a user in OIM or creates a groups and roles in OIM through that. And that web services was later called by a legacy uh, portal, which was developed in Java. Uh, uh, we cannot directly use those OIM Java classes into libraries into old application. So we had to build like a web service in between, which does the compatibility thing. Also, like if your application requires transactional things like calling a Visa or Mastercard and that kind of thing, so they network Visa and Mastercards and other PayPal. They expose the web services from their system. So we can use those systems actually to call the different payments gateways. So these are little real world use cases that we have worked on and I have seen. So another is casual data movement from .NET. So I gave the example in and outbound is similar to it. So we had a requirement at Goa, which we read data from the .NET application, and SOA processes basically read through web services. It reads data from .NET, and import into the new Oracle system. So these are little real world use cases, and I'm sure many more to come. So let's dive into how you build a SOAP based web service. For SOAP based web services, these are the 6 steps you have to do. You have to create XML schema. XML schema will tell us what are the input parameters, what are the output parameters of your web service. And the next, you have to create a visual document. Visual document will tell, okay, I have this operations on my web services, and these operations takes this input and that output. Third step is to implement the logic. You can call whatever you want in the web service. You can call database, JDBC, and you call another web service, another thing. You can read a file from operating system and whatever you do. Then you deploy this web service to server, and then once it's deployed, you will have a URL of your web service. Step 5, you create a proxy client, which is a required job of a client who want to use that web service. And 6 is basically you call that client from your application. So let's create a SOAP based web service, very simple, using JDeveloper. So I have a JDeveloper open here. I have a 12c version. You can download from Oracle website. Let's go and see how you can download it. So you go otn.oracle.com. Okay, so I think I got disconnected. Do you see my?
No, it's not.
Okay. Okay. Looks like it is slow a little bit. Okay. So now everyone see my OTN web page. Uh, you go to Downloads tab and you say JDeveloper and ADF. Click on it. You accept the agreement, sign in with your ID, and download the Studio Edition of JDeveloper 64-bit. If you are using 64-bit machine or something, download that and simple install it. Once this is installed, you I have on my desktop this icon. Uh, Double click it so you will see this screen. So this is JDeveloper, which is a developer tool for all Oracle applications. You can build ADF applications, you can build mobile applications, you can build SOA applications, Web Center portals, UCM, Enterprise Content Manager. So everything the Oracle direction is to actually use this single tool, and it has different extensions to build applications. So let's build a new application. It's called, I'll take a custom application and I'll say, okay, AST web service example. I'll just give a package name. So it's asking for to create a project. I'll say this is my SOAP based web services, and technology I want to use, I'll just pick up SOAP web services from here. uh, in a selected. So you see all these technologies that are required to build SOAP services will be available to me in this project. I'll say next and I'll just hit finish. So so what it does now, you have a project, very empty project called SOAP here. So my first step is basically to create XML schema for it to give the input and output parameters. So let's create right click the soap, click new, and go to from gallery. You have to select XML on the left panel and select XML schema here. Click OK. It will ask for the name of the XML schema. So I will say that my XML schema, and I'll say OK. So this is the screen you see. You are actually creating XML schema in graphical interface. So previously, like when the technology started, you all do this manually using source. For example, if I hit this source button at the bottom, you see these all XML automatically generated. But I'll work in the design view. So this is my input parameter. So I'll say my input request, or let's say my request. So next step is to drag the sequence from the component palette here, and then drag this element from here to there, and you will say that my employee ID. So this is your input parameter. My web service is what it will do. It will take one input parameter and it will like query the database. I'll not do it now, but you can do it like you pass the employee ID and you can get the department name of the employee or a full name of the employee from that web service. But I'll keep it simple here for the basic understanding. I'll so next is to create a response. So I'll create another element here, which will be my response, and I'll create same thing sequence, and then I'll create element of it. So I'll say my employee full name. So now I need to define the data types of my parameter. I'll select my employee ID, go to the properties, and then there is a type called I'll say my input parameter is XSD integer, and I'll define the output parameter as a string. So I'll say XSD string. So now I have this in XML schema defined. I'm actually talking slowly because I see the screen is updating little late. So follow me. Now next step is to create a WSDL document. So I'll create new and I'll say WSDL document. I'll give it a name, my employee WSDL, and just create OK. So this is my WSDL document. Uh, there is a requirement of XML schema to be inside this web in folder. So I'll actually move this schema here. So I'll right click my XML schema, I refactor it, and I'll move it to public HTML webin. So otherwise it will throw error later. So now this file move here in this web inf folder. Now my WSDL document is there. If you see the source of WSDL, it's very XML. You cannot understand really. It's very complex to work with. but JDeveloper will actually allow you to easily develop web services. Uh, so let's uh, now I have to create operation in my WSDL document. So what I'll do, I'll just click this WSDL, drag it little down, so you see in the middle now, then drop it. So you can see both input parameters and the ports and the WSDL document. So let's go to the components page. Select your WSDL document, go to components page, and you see this operation here in the component. Drag this operation. So first step is to create a port type. This is the port types which will define that what are the operations exposed here. So I'll just click this green port type and I'll say my port type. So now I have a port created. I'll drag this operation and drop it on the port. Now my operation name could be anything. I can say hello. This is my first operation of this web service. So I say hello, and I don't have to define anything yet. I just say okay. You see now in the down you have created operation called say hello. Now the next step is to define input and output parameters. So I'll click this my request and I'll drag it to my input parameters and drop it. So now this this web service will take this input parameter which is of this type. Same thing I'll do with my response as output and drop it to my output. So we don't need this document now, but you see the port type in the WSDL document you define. I have an operation called say hello which takes the input parameter of my request and output parameter of my response. So this is your first steps of creating a WSDL document. Next you will drag this port and drop it to your bindings and select SOAP 1.2 standard binding. Just hit OK. These are like complex standards of web services. And same thing you will do, you will drag this bindings and drop into the service. So these services are exposed now to your client. Save all the operations. Uh, so now we have completed two steps. We have created the XML schema which defines what is request and what is my response. I have created a WSDL document which defines what operations I have created, and now I have to build a web service. So right click this WSDL document. So right click this WSDL document and go down. It's called select the option create web service. You will see a wizard. Still not coming up on audience screen. Do you see the wizard?
Yep.
Okay. So hit next. You tell your project, select the standards. Everything you have to do is basically uh, keep basically default values are sufficient for to build a web services. So you just select add service interface. If you want to change the package, another. So on my screen currently I see policies. Okay, so these are options basically to uh, attach policies to your web services to secure them, and we will cover in the later slides. Currently I'll go just basic no policies. These are all defaults we can take just to build our web service. When we finish, uh, JDeveloper will do its magic and it will expose this my port impl class as a Java code. It generates all the complex Java code for us uh, for this web service. So let me save my project, and I can run this web services now. But what I'll do currently, I'll just respond. I'll actually basically set my web service to it return some text. So what I have to do actually create implement the logic. So I'll say okay, and I'll say response dot set my employee full name. These are all the parameters. I'll just, and the return will be my basically response. So this is a little very basic implementation of the web service. The method say hello. So I can actually call my database here through Java code. I can call read a text file. I can generate whatever I want to do in this method. So let's actually test this web service. So you right click this my port type impl.java and you pick test web service. When you click this, JDeveloper will actually deploy this web service to server internally, and it will give you this screen HTTP analyzer, which you see that it is taking one input parameter called my employee ID, which I'm not actually using it, but you can do it. I'll just pass some parameter and I'll click send request, and you see my web service respond, my name is Zeeshan Baig. So this is very basic. We have seen how to build SOAP based web services, but it requires quite a lot. Like you need to prepare the XML schema, you have to prepare WSDL documents and all these Java implementation logic to make it work. In HTTP Analyzer, you have these credentials options. If your web services are secured, so you select credentials and all different. And if you see this WSDL document I was talking about, this is the URL of the WSDL document. So when you click, it is actually opens the WSDL document. Any web services, uh, you can actually copy that WSDL document and see in the browser. So I copied this WSDL document. I'll go to my browser. I'll paste the URL of my WSDL document, hit enter. So you see this XML document, basically a WSDL document, which will tell me what are my port types and what operation my web services is exposing. So based on that actually, and if there are any security policies attached to my web services, I can actually I can see the it will be listed here. So basically, this is, and I know that the input parameter it needs and output parameter it needs. So that's how basically I every WSDL document you can see. One of the WSDL documents, let me see if I have. So this is the WSDL document from Oracle Cloud Applications. So Oracle Cloud ERP. So you see this is very long WSDL document and it's very complex. So but there are different tools that will allow you to actually understand this document much better. So we'll see some examples of when we go to the testing. So this is about SOAP web services. So let's continue on the slide. let's so we have covered SOAP, and now next step basically is to create the REST-based web services. So for REST-based web services, there is no WSDL document involved. There is no uh, uh, XML schema involved and anything. Everything actually you do in your implementation logic. You define what input parameters it will take, what output will we take, and then based on that, you just expose your regular Java method or any technology method as a REST services. So it's very easy to use. Let's see how we can build REST-based web services in JDeveloper. So, so I have this JDeveloper. Let me create a new project. It's a little slow on the audience view. Yes, still it's taking time. Just okay. So still waiting for it. Okay, so let's create a new project, and I'll create a custom project again. And I'll call this project name as REST. The screen is slow, so I'm holding on. So in the REST, you will just select the technology, REST web services. You will for REST web services, all you need is the Java language and REST web services in Oracle world. If you're developing in .NET or something, it's you can build in any technology. So we'll create this, and now we have a REST project. I right click the REST, and I'll select a new RESTful service. So the wizard will come, and I'll say I need a REST 2 version, and I'll select REST for service from new. If you have existing Java class, you can expose it as a REST web service. I don't have any, so I'll just create a new Java class here. I'll keep it default. These are different methods I mentioned in the REST. You have get, post, put, and delete. I'll just take it get method, and once I click finish, it creates a Java class which is called generic resource, and it gives me a method called get data. So it is asking that you do implementation logic here. So what I'll do, I'll just return the basically a text. So I'll say just okay. This this call is from REST web service. So this is the method my return this string method. This method is basically a returning string, and I'll call this data. So far, like I'm good. This web service I can test it, but I will not see a response back. So I have to define what this method will actually produce. So I have to mention like add produces, and I'll say okay application slash XML, and I have to define a path also. Just say that it doesn't takes any input parameter. So this is very basic example of web service, REST-based web service. I'll just right click and I'll say, okay, test my web service. So this REST-based web service doesn't take any input. Uh, there is no input. I just click the send request button and I get a response called this call is from REST web service. And I can see all the details and all this. So this is very basic example and how easy it is to create REST-based web service compared to SOAP. For SOAP, you have to have these WSDL documents and all this crazy stuff. But for REST-based web service, it was very easy. You just have a method, you define what are the input parameters, what type of data it returns, and you just simply call that method. So that was example of a web REST-based web service. So next slide. Okay, so now we come to the testing tools. So it is very important when you build your web service, you have to verify like how your web service is performing. Is it calling on each every request, or it's caching data, it's reading from cache or not? And what input parameters are required and what are optional parameters. So everything you have to actually properly test, and the performance is very important because calling too many times web service could cause overhead on your web server. So you see most of the, and security is also very important. If you don't want every person to actually call your web service APIs and calling on every request, every page load, and your server crash because of it. So I have a tool called SoapUI, which is very popular tool. Let's see the example of SoapUI. In a browser, first what I'll do, like I'll just Google SoapUI. SoapUI basically for all the functional testing of your web services and all this. Uh, you can download from here. They came out with a open source edition and different editions you have, so you can download the free version of it from here. So I've already downloaded on my machine. I'll double click this soap UI. So first step, what the best practice is basically without doing any complex things. Once you have your web service which you want to use, the good thing, best practice is to actually test in the SOAP UI, so you can understand what kind of input parameter it takes, what kind of output parameters it takes. So in my example, let me copy my WSDL document that uh, I was hosting. The web service I built, uh, Hello World web service. So I'll right click the projects in my SOAP UI and I'll say new SOAP project. It will give you can give a name, and you have to define the WSDL document because it's a SOAP request, so it requires a WSDL document. So I just paste my WSDL document and I say okay. The SOAP basically it's give me the easy way of what this methods web services is exposing and what kind of request. So I'll just click this request one, and it's asking for, it's created the XML format. I I can pass whatever the employee ID is, and click play, and I got the response from the web service in the XML format on the right side. Still not coming, so bear with me. So yeah, you see now on your screen on the right side you have the response back, which and the text what I was using in my web service. My name is Zeeshan. So this is the way of testing SOAP. Now let me also test this REST-based web service that I have built. So I'll go to HTTP Analyzer. I'll copy the URL, and I'll create a uh, new REST service, and I'll just paste that REST web service URL, and it creates a request, and there is no input parameter for this. When I click this, so I get a response called this call is from REST web services. So this is a very common tool to actually use the web services, test web services and see what input parameters takes, what output parameters. And you see it's very easy using REST-based web services compared to SOAP. SOAP you have hardly strictly XML data, but in REST you have a choice. You can actually use JSON format and other. So there is a uh, you can learn more about the JSON format in the next the URLs I provided. So we are almost done with the session. Just a couple of slides. So the next slide is so talk about security. So security is very important for web services. You don't want anyone to actually call your web services without permission, because web services they expose data, and this data is sensitive, and the data mostly communicates over the web. So I'll show you what are different things you have to keep in mind when you talk about web services and secure them. So so first thing is basically you have to enable encryption. So SSL, basically you host your web services on those servers which supports SSL protocol. TLS protocol, example of you see HTTPS in most of the sites. Even if you go google.com or anything, you will see that the protocol changes to HTTPS. So basically, this tell us that the communication is happening between the client and the server is all encrypted. So encryption means that the data will be in a non-human readable format, and it's not easy to actually decrypt that data to see. So you have a lot of sensitive information going. You put your credit card information, you put your social security, and all these sensitive data you submit over the web. So SSL basically encrypts that data. So make sure whenever you use web services, you host them on a server and enable encryption and SSL there. Next option is to enable authentication. Authentication, like I've show you that in HTTP Analyzer and the SoapUI, you can actually pass username and password with every request of of the web service call. So let's see, I have SoapUI open here. If you go down here, you click auth. So there is option you can actually add a new authorization with this request. So uh, if your basically web service need authentication, so you just say, okay, I add authorization, and you pass username and password with every request you test in this SOAP UI. So there is a like option you actually, if your web service enables and requires authentication, so you have to pass these parameters with every request of it. Go back to slides. Another option is basically called API keys. So what it does, basically your service provider who is exposing web service, they actually create some kind of key string which is very complex, and you have to pass that key string with your request in the format, like with the web service there will be an input parameter which will ask that string. So you pass that string with every request, and then the server will evaluate that request, and it's actually then counts, okay, how many requests you are sending. Basically it's like a primary key. With every requester basically will get one key, and the server can actually verify against that key how many calls you have done, and is it authentic call or not. So that string is very usually comes very in a very complex string. And another option is called security tokens. So it could be a physical device or something. So there are different methods of security uh, you can secure your web services against. Uh, so there are time-based security also, which changes that password every 1 minute, and you have to enter through your you have to see that number, whatever number is on your physical device, and or a mobile app. You can actually pass that string with every request. So let's see the example of API keys. I have show you that Yahoo website. So let's see. So waiting. So connection is slow. Sorry about that. So I think I can take questions also. We are almost done with the presentation. So type your questions in the chat, and I'll respond one by one. So if you see my screen, also Yahoo Weather API I've shown earlier. Uh, there is a option called Get Your API Keys. So this is basically you actually create your keys on their Yahoo server, and you they will give you a string, and then you can either some allows you to actually download to your machine and then attach with every request, and some actually you just pass that parameter as an input parameter. So this is basically how you secure. I think the slide is still not. Yeah, Okay, let me pause my screen and start again. Still not coming up. I think connection is very slow now. Is it coming? Okay. So in summary, to summarize it, uh, now we are familiar with the web service. What they do, basically, it's a framework to communicate between two devices. It's not technology specific. Many vendors like Microsoft, Oracle, and others, they support it, and every latest technology basically support it. So it's been a while web services exist. We know the XML and JSON message formats. XML, basically you have tags with every attributes, every element. JSON is basically works with the brackets and less data. We know the main standards of web services are SOAP and REST. And SOAP based requires a WSDL document and XML schema import and all these strict rules with it. And REST is more user friendly and easy, and that's why the mobile community adopt REST, because it's lightweight and it works with only data. We know how to create web services. We work with the JDeveloper. We created SOAP based web service. We created REST based web services. We tested with the HTTP Analyzer and SoapUI. We have seen some real-world examples how we created used web services at AST and others. So that's pretty much from my session, and I'm open for Q&A. So if you guys want to talk, maybe uh, ask question, I'll unmute everyone. So just think I cannot unmute. So you guys can put questions in the chat, or you can email me also if you have any questions. Uh,
You're gonna send out the slides.
yeah, and I'll send out the slides to everyone at AST. So if you have any questions, I think I cannot unmute everyone. So maybe raise your hand so I can unmute you. You see the option raise your hand, or type your questions in the chat. There is no unmute option. I don't see.
Expand chat, see if anybody chatted.
So
Because nobody's asking.
so I think we are good for today. So there is no questions, which means either I did very good job, so you guys understand, or I did very bad jobs. So thank you for attending this session, and I appreciate your time. Um and if you have any questions, you can send email to my account. Again, my name is Zeeshan. So thank you. Any questions? I'm happy to answer you.
You also recorded it.
Okay, so I have recorded this session, and Bailey will send out the URL for this to everyone. Thank you.